Welcome to this optional, that's important, optional module, where I want to introduce you to the JavaScript basics. And this module is really just a quick refresher. I do expect you to have some basic knowledge about how JavaScript works, what you use it for, and its base syntax. This module does not replace that. You can't really use that module with zero JavaScript knowledge, or at least it will be very, very challenging. But if you only got some very basic knowledge, or it's been quite some time since you worked with JavaScript, then this module will be a great refresher. Please skip this module if you already know JavaScript though, because then this module is not for you. So you don't have to be an expert to skip this. If you know JavaScript and you also know some of its next-gen features like the REST and spread operator or object destructuring, so a bunch of nice things that we can do in JavaScript, definitely skip this module and maybe come back later if there is some feature you don't recognize or you're not sure what it's all about. If you don't have that knowledge though, this module is for you. And also have a look at the next lecture where I provide links to helpful resources in case you're brand new to JavaScript, because there are some free resources that allow you to get started with JavaScript, after which you can come back to this module and to the rest of the course where you will need that basic knowledge. So now that we know for whom this module is, let me summarize JavaScript briefly. JavaScript is a weakly typed programming language. It's an object-oriented programming language, and it's very versatile. Now, what do I mean with that? Weakly typed means that we have no explicit type assignment. JavaScript knows types like numbers or text, which is called string, or booleans, which is true or false. But it doesn't force you to define which type you're using in a variable or in a function. And indeed, you can also have a variable where you store a number, which you then suddenly change to a text variable. So you can switch types dynamically. In other languages, this is differently, and whilst this gives you greater flexibility to be able to change it and to not have strict typing, it also can lead to errors. So it is just something you have to be aware of. Object-oriented simply means that data can be organized in logical objects, and we'll see these objects in this module. And one important concept here is that you have to be aware about the difference of primitive and reference types. And attached to this lecture, you'll find a link to an article and video I created for my free YouTube channel, Academind, where I do dive into primitive and reference types and where I do explain the difference and why they are important. So definitely check that out if primitive and reference types don't tell you anything. Regarding the versatility, well, we can see that in this course. JavaScript runs in the browser, and this is actually where it comes from. But you can also use it with NodeJS to run it on your PC outside of a browser setup, or also on a server therefore. And that is exactly what we'll do in this course. We'll build a web server with Node.js. So we got this broad versatility of being able to use JavaScript on different platforms. And you can also perform a broad variety of tasks with JavaScript, also depending on the platform you're running on. You can, in the browser, listen to user events, re-render the DOM, and on the server or on a PC, you can work with files, with databases, a lot of cool stuff. So this is the summary of JavaScript and what makes up the language. Let's now dive into some core features, also some core next generation JavaScript features, which are supported by Node.js. And let's see some things we'll see throughout the course. For that, let's just play around with JavaScript. And I'm in a brand new empty folder, which I opened with my IDE, Visual Studio Code. And in there, I'll create a new file and I'll name it play.js. The name is totally up to you though. Now let me start with some core language features, variables and functions. And again, you should definitely dive into a core JavaScript resource like the ones I linked in the second lecture of this module if you are brand new to JavaScript. So I by now do expect you to know what variables, functions are, I also expect you to be aware of what if statements or loops are. These are all core things you gotta have set by now because they are crucial for JavaScript, no matter if you're using it in the browser or on the server. So for variables, you might know this syntax with the var keyword. You can have var name and, for example, store max in there, right? This would be a variable, and now you can use that, for example, to simply output it like this. And if we now run this file with Node.js by running node play.js, this is the command we have to write in a terminal, navigate it into that project folder, so into that folder where I'm having this play.js file, then I see max down there, right? So that is some JavaScript code. We can also create another variable, age, which now would be a number. It's not enclosed in quotation marks. So this first one is a so-called string. This is a number. We can also add a third one, has hobbies, and that would now be a Boolean. These are some core types JavaScript knows. True, false are Booleans. Numbers are, well, numbers. They can also have decimal places. These are strings. And now here, I can also define a function with the function keyword, summarize user. This is how you create a function JavaScript. And there we could return something. Functions can return values with the return statement. They also can get input like user name, user age, and user has hobby. You can name these arguments as these things here are called, however you want. These are now local variables, only available inside of the function, not outside of it. And then you can return name is plus username plus, let's say, some text with a comma, a white space. Age is white space, user age plus, and the user has hobbies, and then user has hobby, something like that. Now here I'm simply returning some text which I'm manually concatenating by hard-coded strings and the dynamic values I'm getting as an argument. Now we can also console log the result of summarize user, and we call a function by adding parentheses after the name, and now we just have to pass in data we expect here as arguments. So we need to pass in 3 arguments here, the name, the age, and has hobbies, so the 3 variables I defined up here. We could have directly accessed them in the function too, by the way. We don't have to take the way of accepting arguments, but this is a purer function which does not depend on anything from outside the function, but gets all the data it works with as part of the arguments, which is a nice way of writing functions. And now, if I execute this, well, then we get this output here. Now, this is just a summary of the features you should be aware of, as I mentioned. I just want you to know, or I just want to be sure that you know how we work with variables, how we work with functions, how we call functions, and that you understand how parameters or arguments in the function are used in there and only in there. We couldn't use username outside of there because of something called scoping in JavaScript. We can then call a function like this and pass in the data. We could hard code the data here or refer to variables, which have to be available in the scope of this statement, which is the case for these variables since they are global variables. And these are variables and functions and how we interact, and these are some core features you have to be aware of. Let's now dive into something more exciting in the next lecture. Now that I had a quick look at the very basics and the core terms you have to know, let's dive into some next-gen JavaScript syntax you'll see throughout this module or throughout this course. Var is a keyword that creates a new variable, and actually it's a bit of an outdated syntax. From now on, we'll use let instead of var, and let also creates a variable. The scoping behaves a bit differently, but we can ignore that for now here. Check out some next-gen JavaScript resource like my ES6 course, or of course also some free resources to learn all about let. But the core reason for using let is that we now also have another way of creating a variable, and with that I mean a variable which never changes, which actually is the case for all 3 here. But let's say we actually do assign a new value to age here, but we never change name or has hobbies. We could absolutely use let, there is nothing strictly wrong with that, but to be clearer about our intentions in the code, and we know that we'll never change let name and has hobbies, we can also use a new keyword available in JavaScript, and that's the const keyword. This creates a so-called constant, and this makes clear that we never plan on changing the value of name or has hobbies. We do plan to change it of age, and that is why we have let. And that is the reason why we have two different keywords for creating variables, though again, these are not really variables, there are constants. Either const or let, depending on whether we plan to change this or not. So now if I execute this, it works in exactly the same way as before. But by the way, if I would try to set name to Maximilian here, and I do run node play.js again, I actually get an error now that I try to assign to a constant variable. So this actually already shows us the idea behind const, and you want to use const as often as possible to be as clear about what happens in your code as possible. And if something should never change, make it a const so that you get an error if you do accidentally change it. So here I'll revert this change, but I wanted to show you how let and const work. Let and const are two relatively new features in JavaScript. Another cool new feature are arrow functions. We can rewrite this function as an arrow function by, first of all, creating a new variable or constant. Since I'll never set a new value, I'll use a constant. And I'll give that the name of my function, so summarize user. The value which I then assign after the equal sign is a function. Now we could already have done it in the past with this syntax. This is another way of defining a function. The part on the right side is a so-called anonymous function, because we don't set up a name after function, but we make it a named function implicitly by storing the anonymous function in that named constant. So we can always call that constant, which holds a function as a value, and we call the value with the syntax, and therefore this is like a named function here. So this would have worked in the past too. It is a way or a different way of defining a function, but we can now also use a new syntax where we remove the function keyword and instead we add an arrow between the argument list and the curly braces. And this arrow is simply an equal sign and a greater than sign. This also creates a function. It's a bit shorter since we saved the function keyword, and it runs in the same way as this function ran before. Now, why would we use this syntax except for the reason that it's a bit shorter? Well, that is already a nice reason, but also there's one key difference regarding the this keyword which JavaScript knows. And attached you find a link to another video and article I created where I dive into the this keyword and how arrow functions help us with it. The attached article and video actually uses the browser, but it's the same for Node.js. So this will be helpful too. You have to know what JavaScript objects are for that, but again, that is some core knowledge I require you to have for this course. In this course, I will pretty much only use arrow functions. So this syntax for defining a function should be something you understand for this course. That this is the name of the function, and then here we have the arguments, and then we have the function body. Now a little side note. There is also a shorter syntax of writing this, or a couple of shorter syntaxes. Let's say I have another function, which I'll name add, and there I get two arguments, a and b, and I just return the sum of them, so the addition. Then you could write return a plus b, of course, and that allows us to run console log add with 1 plus 2, and if I now run node play.js, we see 3 here as a result. If you only have an arrow function with one statement, which happens to be the return statement, or which you are fine returning, well then, you can omit the curly braces, you can omit the return statement, and you have to omit it, and you just use the function like that. This simply is the same syntax as before with the curly braces and with return, and this function will now always return the result of this statement here. So now if I execute this again, we still see 3. Now if I would adjust this function to, let's say, always add 1, then I have just a as an argument, let's say, and I return a plus 1. Now I could call this by console logging add 1 to, let's say, 1 here. So the result should be 2. And I can, of course, execute this, and indeed I see 2 here. Now, in such a case, you already saw my auto formatting removed the parentheses I had there previously. Because if you only have one argument, and that's the case really for that case only, if you have one argument only, then you can just have the argument name here without parentheses. And it will work just as it will work with parentheses. So both works here. But you typically use the syntax without the parentheses. And again, my IDE auto formatting removed them for me. If you have an arrow function with no arguments at random, then you have to specify an empty pair of parentheses though. You can't have just a white space. You have to have that empty pair. And then you can have your code there, which obviously uses no arguments because that's exactly what I want to show here. So here I could have add random called like this without any data passed in. And now we see 3 here from that result. So these are arrow functions and their different syntaxes, and you will see them throughout the course, and you should recognize that syntax and understand how they work. Again, for a reason why to use them, check out the attached article plus video. Now let me get rid of that existing code. You find a snapshot of the code we wrote thus far attached to the last lecture. And let me write some new code. An important thing you work with, or important data structure you work with in JavaScript, are objects. You could have something like the person object, and you create an object typically with curly braces, and then in there you have key value pairs. You define the key by simply typing, well, whichever key you want to use, let's say name. Then you have a colon, and you must have that colon, and after the colon you have your value, in my case a string max. And then with a comma, you can add another key value pair, age 29. Now this is an object, and I can log person here. If I now execute play.js, we see that object being printed here. Now objects allow us to group data together. You can also not just have variables in there, so to say, but you can also have functions in there. For example, a greet function, and there you can simply have an anonymous arrow function, or an arrow function in general, as a value after the colon. And then in there you could have console log hi I am, and then the name, and this would now be accessed with the this keyword. Instead of an object, you have to use this to typically, and there is something special about this, which I showed in that video I linked before in an earlier lecture, but typically this refers to the surrounding object. And now we can use the dot notation, so dot, to access properties or methods, so variables or functions inside of that object. So we could now use this name. And now I can use that person and call greet with the dot notation and executing it as a function. So the dot notation is important on this, which refers to the object, or on you, referring to that object which is stored in this constant here. And now if I execute this again, I'm saying, hey, I'm undefined. Now why is that? Well, the reason for that indeed is what I taught you about arrow functions. This now here refers to the global scope, to the global node runtime scope, and not to this object. To have it refer to that, we either have to use the old school function, like this. Now if I repeat that, I'm saying, hey, I'm Max. Or we use a slightly different approach or syntax here in an object, and that is you don't use an arrow function, but you use greet like that. So you omit the colon, add the parentheses after the key name, and then without a function keyword or anything like that, you add your function body. And now this is a method of this object, and you see, hi, I'm max2 now. So this is something important, and this is the syntax you'll see me use throughout this course, without the colon, parentheses right after the key, and then the function body. Besides objects, another crucial data structure in NodeJS or in JavaScript in general are arrays, like hobbies. An array is defined with square brackets, and in an array you can have any data you could normally use too. You can use strings in there like sports and cooking. You can have numbers in there, and you don't have to use one and the same type in the array. Here we are mixing text and numbers. You could have arrays with just text, just numbers, and so on too, of course. You can use Boolean values, and you can even store objects in there or other arrays. That is all possible. Now here I'll have an array of text though, and you can use for loops to go through that. With this syntax, for example, with the for off loop, where we store each element for each iteration in that hobby variable. And now if we do that, we would execute console log 2 times because we have 2 elements and we're looping through all of them. And I'm outputting the current value we're currently looking at, because this will change for every iteration. Going through it from left to right will output that for every iteration. So now if I run this, we see sports and cooking printed in 2 lines because this executes 2 times. So these are arrays. The for off loop is interesting. And it's also interesting that in JavaScript, we got a lot of built-in methods we can use on arrays. So on hobbies, on that array, if I add a dot, my IDE suggests a lot of methods I can use on arrays in JavaScript. And all these methods help me go through the elements in the array, manipulate them, get a subset of that array, whatever I need. Often you'll see map, for example, which allows you to transform an array or transform the values. And map will actually return a new array, so it will not edit the old one, but give you a new one. And we can print that new one here actually. And just to show that the old one was not edited, we can print that right below. And now map always takes a function where you define how to edit that array or how to edit the elements in the array. That function will be executed on every element in the array, one after another, and you return the updated version of the element. So here we would get our hobby. You can name this however you want. And here I'm using an arrow function with one argument only, hence no parentheses. And in here, I'll return the edited version. For example, here I could take my old hobby string and simply add hobby in a white space in front of that. So I'm simply constructing a new string which keeps the old hobby name, but adds hobby : white space in front of it. And yes, since we only got one statement in that arrow function with a return statement, we can get rid of the curly braces, get rid of return, and just return it like this. This would be the equivalent. And now if I clear this and I run play.js, I see the old array was not edited. That is my second output here. It's coming from this console log, where I console log the original array. But the result of my map here is a new array where I have my edited items with hobby added in front of every item. And this is something you'll see me do quite a bit in this course. Use that map method. And as I mentioned, it's only one of the many methods provided here. Always check out the docs on MDN to learn more about all these methods. Link can be found attached to this video. And make sure that you understand how they work, or that when we use one of them in this course, you can quickly look that up in case it's not clear what exactly that does. Though, of course, I will do my best to explain it when we use it. But these are arrays, very important data structures, and some very important methods you can use on arrays. Now that we learned about objects and arrays, there's one common misconception I sometimes see in the Q&A section. Please Check out that video I linked earlier in this article where I talk about primitive and reference types in JavaScript, because that is a crucial concept. Objects and arrays are so-called reference types, and you'll learn all about that and what that is in the linked video, so I'm not going to re-explain it here. They are reference types, and therefore when I store an array in a constant hobbies, I can still edit this array without violating the restriction that constants must not change. Let me prove that to you. If I comment that out, and I add a new line here, and I use another method, the push method, which allows me to add a new element to the existing array. So this will not return a new array, it will add it to the existing array. And here, I will add programming. Now, if I now console log hobbies after pushing, and I run node play.js, you see that is the output. And we get no error about editing this constant. The reason for that is that reference types only store an address pointing at the place in memory where that array is stored. And that pointer, this address, has not changed by us adding a new element. So the thing stored in this constant is just this pointer, just this address, and this has not changed. Therefore, our constant value has not changed. The thing it's pointing at has changed, but that totally does not matter here. And this is something you have to understand so that you don't wonder what's going on when we do edit, in quotation marks, a constant value. We're not really editing the thing that is stored in a constant, we're only editing the thing that constant thing is pointing at. In modern JavaScript, there are two important operators you also should be aware of, since I'll be using them throughout the course as well. And that are the rest and spread operators. Now, specifically, the spread operator is one we'll use quite a bit. Let's say we want to implement a pattern where when we add a new hobby, we don't edit the original array, but we create a new array with all the old values and the new value. This is actually a pretty common pattern called immutability, where we never added existing values, but where we always replace them with copies plus the changes. And that is also a pattern I'll use quite a lot in the course. The idea behind that is that we avoid errors because we always have this clear approach of copy, then edit, and don't edit existing objects, which might lead to more unreadable code. Now, to copy an array, let's say here I create the copied array, we got a couple of possible techniques. One of them is to use the slice operator. Now, if I output copied arrays down there and I run node play.js, I see sports and cooking, so I did indeed copy it. Slice simply copies an array. We can pass arguments to narrow down the range of elements we want to copy. With no arguments, we copy the entire array. Now, instead of slice, there is also a different technique. We can create a new array with square brackets, and we could add hobbies there, right? Now, what happens if we execute this? What will we see in the console? Well, if I hit enter, we see, well, it looks like a copy on first sight, but actually it's an array with another array in it. So the outer array has only one element, and that's the inner array. So it's not a copy, it's just a new array where the first element is the old array. And with that, I mean the exact same object, not a copy of that. So we just created a nested array here. That, of course, was not what we did want to do here. And here we can use the spread operator. The spread operator are three dots we can add in front of an array or of an object. And these three dots are an operator just as the plus or the minus are. And they do one thing. They take the array or object after the operator and pull out all the elements or properties, so all the elements of an array or all the properties of an object, and put it to whatever is around that spread operator. In this case, we got square brackets around the spread operator, and therefore all the elements which are pulled out of the existing array are added to the new array. And therefore, if I now run this file again, whoops, and I save it before running it again, now we see this was the output of the old approach, the nested array. Now we got no nested array anymore. We got one array, and this is now a copy of the old one because we take the spread operator to pull out these elements and add them one by one to the new array. So this is something you'll see me do a lot to copy existing arrays or objects. There it would work in the same way. We could have our copied person by using curly braces, then the spread operator, the three dots, and then the old person. And now if I console log the copied person here, and I execute this file again, this is our copied person here because I'm pulling out all these elements from that object and I add it to a new object. So this works for both objects and arrays, and it is syntax I'll use quite a bit in this course. Now this is the spread operator. I also mentioned the rest operator. And the rest operator is essentially the opposite. Let's say I have a function which I'll name toArray. It's an arrow function. And there I expect arguments arg1, arg2, arg3. I want to return an array that contains these arguments. Whoops, and I should add an equal sign here. So I want to return an array that contains these arguments. I can return square brackets here, of course. And then the first element will be arg1. Then I have arg2 as the second element and arg3 as the third element. Now I can console log toArray, and I pass 1, 2, and 3 as the three arguments to that function. If I now execute play.js, we see an array with 1, 2, and 3, these three elements. So this is working. But this is totally not flexible. What if we want to pass 4 arguments? Well, we could call it like that. JavaScript actually allows that, but of course it doesn't get added because we only work with 3 arguments here. What we could do is we could use the so-called rest operator there. Dot, 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 and then just args. And this will actually take all the arguments, how many we might specify, that doesn't matter, and it will bundle them up in an array for us. So here, args will be an array, and I can just return that actually. And now if I re-execute this with toArray getting 4 arguments, you see now I have my array with 4 arguments here. So the rest operator looks just like the spread operator, 3 dots, and it's the place where you use it that defines how you call it. Are you using it to pull elements or properties out of arrays or objects? Then it would be the spread operator. Are you using it to merge multiple arguments into an array, and you use it in the argument list of a function? Then it's the rest operator. It's the same operator by the syntax, or from a syntax perspective, the name differs depending on the place where you use it. I'll not use that syntax a lot in this course, but it's still nice to know. But being able to pull out elements or properties, that is something you should understand, because that is a syntax you'll see me use quite a bit throughout the course. Rest and spread are important syntaxes to know. Now I want to dive into another important feature, and that is destructuring. Now let me comment out this code down there, and let's begin with object destructuring. I got my person object, and now let's say we have some code where I only need the name. So I have a new function, print name, let's say, and that actually takes the full person object, because for whatever reason we wrote it like this, or we simply have a function where we are able to get multiple arguments or a full object because some third-party package always gives us that person. We can't change that. So we get the person here, and I only want to console log person.name. Now that is totally fine of doing it like this. I can now execute print name here. Now I need to pass person here. Now, to avoid naming confusion, you can name this here however you want. So here we could name it person data. And inside here we use person data. So that function does not use that person. It just expects any person data. We then call that function and pass in that person as an argument. And now if I execute that file, I see Max here. This is stemming from this line here. Now, of course, we can absolutely do it like that. And we always get person data because, again, let's say this is a function which is actually called by some third-party package, which is a pattern you see quite a bit throughout this course. Now, therefore, we can't change the data we get. But in this function here, we are only interested in the name. We can then use a syntax or a feature called object destructuring, where we add curly braces here in the argument list. And we then specify the property of the incoming object we are interested in, name. That is this property we have here. Then this will be pulled out of the incoming object. The other properties will be dropped for this function, and it will be stored in a variable named name, which we then can use in there. So now if I execute this again, I also see Max. But now we're using this destructuring syntax. And we can pull out the h2 if you wanted to, or the greet function. So that all works, and that is just a syntax we can use that allows us to write a bit of a more understandable code where we are very clear about what we need from the incoming object, and which then gets stored in a local variable that we can just use in this function. And you can, of course, not just use destructuring inside of a function. You can also use it outside of there. You can create a new constant here, for example, and then the syntax will look like this. Curly braces equals person. Curly braces on the left side of the equal sign are something we don't see that often in JavaScript because typically it's wrong, but for destructuring it's correct. And then here we can have the name and the age, and this will create two new constants which hold the values stored in name and age. So these names here have to match the property names of the person. And now we can console log name and age like this. If I now re-execute that file, this output here is coming from this console log, and the values we're outputting here are retrieved via object destructuring. Now there's also not just object destructuring, you can also destructure arrays. So if we go back to the hobbies, which we have here, well, then if we would want to destructure that, we can also create a const. You could also use let, by the way, the same for the object destructuring if you plan on changing it. You could use a const for hobby1 and hobby2 wrapped in square brackets, and then assign this to hobbies. And now if you console log hobby1 and you console log hobby2, and you execute that file again, you see the two hobbies being printed there. Please note there are no square brackets around them in the console log because we're not logging an array here. We are logging two individual values which we got via array destructuring. Unlike the object destructuring, here you can choose any names you want because in arrays your elements have no names. They are instead pulled out by position. So this will always be the first element, this will be the second element. In objects, you pull them out by name, by property name. So that is destructuring, and this is also something used in this course. It simply allows us to access elements in objects or arrays quickly by their name or position and to drop, and that does not mean delete, they're not getting deleted, they're just not used in our function or whatever we're writing. So to drop the data we don't need in that specific code snippet we're working on. Now, I cleared the play.js file again because to conclude this quick refresher module, I'll dive into another core concept, and that is how to work with asynchronous code. And for that, we first of all have to understand what asynchronous code is. Let's say I set a timer with setTimeout, which is a function built into NodeJS. There, we define a function that should execute after a certain timer expired. Here, I'll use an arrow function. You could use a named function, whatever you like. The second argument is the timer. Let's say 2 seconds. You express it in milliseconds, so 2 seconds are 2000 milliseconds. In there, I'll simply log timer is done. If I now run this file for 2 seconds, nothing happens, and then we see timer is done. Now this is asynchronous code because it doesn't finish immediately. And it would even be async code if we had 1 milliseconds there. So if it's super fast, it does not happen immediately. In other code snippets, like if we have console log hello and console log hi, these two snippets are synchronous code because they are executed right after each other. And yeah, technically, of course, Node will take some time to execute them, but there is no delay other than your hardware, so to say. And therefore, this is synchronous code. This is async code. Asynchronous because it does not execute or finish immediately. It takes a little time, even if that's super short. And indeed, if I execute this file like this, you see hello and hi before you see timer is done, even though it's super fast. Because Node.js and JavaScript in general does not block your code execution until that is done. Indeed, here, it will recognize this so-called callback function. So a function should execute in the future. It should call back later once it is done. So once this timer expired here. It will just recognize that and will then immediately move on to the next line and will execute all the synchronous code and then execute your async code once this is done, which is why we see hello and hi first, even though in our code, timer is done is printed first. And that is a crucial concept you have to understand in JavaScript and especially in Node, and I will come back to that throughout the course because it's so important. Now, when working with that, and I'll increase this to 2 seconds again to make it even clearer. Then you will see, again, our sync code runs, and then after 2 seconds, this code runs. When working with async code, we get multiple techniques of, handling it. The callback function is one, the oldest one, and you'll see it quite a bit, especially in Node.js. There's nothing wrong with it, but you'll face a problem if you have a couple of depending async operations. So here we set the timer, and now let's say I create another function which I'll name fetch data, and in there I will also just set a timer because I don't want to set up some database or something like that where we fetch data from. We'll do all that throughout the course, of course, no worries. So here again I have another timer in there, which takes like 1.5 seconds. And now here in fetch data, I need some way of, doing something when this inner timer is done. So here I will actually expect an argument, which I'll name callback, because this argument will be a function I will eventually call in my inner function here once I'm done with the timer. And there I can pass done as a value. Now in the place where I use fetch data, let's say that's inside of this set timeout call, I call fetch data like this. There I now need to pass another callback. And here I will get the text passed by the callback in my function when I execute it. So I will get some text here and I can console log that text. Now this might look confusing. In the end here I'm creating my own function which gets a callback, so that I can define a function which should execute once this inner timer is done from some other place. So from this place here, this is the function which effectively is passed in as the callback. And I'm executing that function here. Now, if I save that and I run that, takes 2 seconds, then the timer is done, and then after 1.5 seconds, I see done. Now, if we have a couple of nested async calls, as we have here, we go deeper and deeper from a callback perspective. And that is why we also have a feature called promises, which we can use in Node.js. Now, often we'll use third-party packages that already use promises for us. So the syntax I'll show you now is one you rarely have to write on your own. That will be done by the packages behind the scenes. Still nice to know. You create a promise inside of our fetch data function here, let's say, by storing it in a constant or variable, and then by using the new keyword, which you use in JavaScript to create a new object based on a constructor. If constructor functions are something that tells you nothing, check out some basic introduction resource to JavaScript, because constructor functions are a core feature in JavaScript. And here you use the promise constructor function, which is built into JavaScript and Node.js. And this actually also takes a callback, which gets two arguments, resolve and reject. You could name them however you want, but these are two functions. And the first one completes the promise successfully. It resolves it successfully. The second one rejects it, which is like throwing an error. You then take your async code and move it into there. And again, you rarely have to write this on your own. Most packages already do that for you and give you the finished promise, which does all the magic behind the scenes, hidden away from you. Here we do it manually. So now in that callback, we have our own function. Set timeout does not give us a promise API, unfortunately. So here we also have to use a callback. But in there, we now no longer use any callback function we get. I get no argument here in fetch data anymore. Instead here, I resolve done, let's say. So I successfully return the resolve value. Now in fetch data, after defining the promise, we just have to return it. And please note, this is synchronous code. So actually, this will be returned immediately after the promise gets created, before the code in the promise is run, which will happen sometime later when we actually call that function and when this timer then completes. So we now return that promise here. And in the place where we call fetch data, we now no longer pass a callback, but we can now use then, which is callable on a promise, and we return a promise. And this simply allows us to now define the callback function here, which will execute once the promise is resolved. Now, what is the advantage of that? If we had multiple such promises, so let's say I call fetch data again in there, then I don't have to use then like this, and therefore I would end up with nested callbacks again. But instead, inside of a promise, and the then block is part of a promise, I can just return a new promise and then add the next then block after the previous one. Like this. So now we have a chain of then blocks. This one gets called on the first promise. Then in the then block, I return another promise. And even if that would not give us a promise, inside of a then block, returning it would convert it to a promise that instantly resolves. And then we add another then block, which is now referring to this promise here. And this is more readable than having infinitely nested callbacks. So now if I run that, we see hello, hi, the timer is done, we see done, and we see done again because I'm calling fetch data twice. So this might be difficult to wrap your head around for the first time. We will reuse it throughout this course, and then it will become clearer. Again, this code is mostly not written by you, but it is a crucial concept that makes our async code more manageable. There also is another way of managing this, async await, two special keywords you can use in modern JavaScript, and I'll have a separate section about this towards the end of the course. I don't want to introduce it here because it can actually be more confusing than this syntax here, and I want to stick to this one to not introduce too many new features at the same time here. Async code is something you have to understand though, and if it's not totally clear by now, that is fine though. You will see it throughout the course a bunch because we have a lot of asynchronous events in Node.js, and I will explain this multiple times. I'll also explain promises again. I just want to ensure that you have seen this by now and that you then have a chance of understanding this, how it works, and how we deal with it. That's it for this refresher module. Obviously, this is no complete JavaScript module. There are way more features which I didn't touch on, and the reason for that is simple. I do require very basic JavaScript knowledge at least. If you got none, check out the resources I linked in the second lecture of this module. These resources allow you to dive into JavaScript for free or with paid courses, whatever you want. And with that, plus this refresher about next-gen JavaScript items or features as well, you are more than prepared to continue with the course and now understand the code we will write throughout the course. I hope this was helpful. Let's now dive into Node.js and write exciting applications.